Okay guys, in this video I will discuss about a steep foundation. Okay, so if you're new to this channel, please do subscribe and also don't forget to press the bell icon so that in future you can be benefited. Okay, so this video is going to be all about the detailing of steep foundation and its design aspect. So my request to you, if you are already familiar with this type of concept, you can simply skip this video. But if you are a beginner, it's my request, please watch this video carefully to understand the basic concepts. Okay. So basically, you know that to provide any foundation of any structure, we may have only three options. First one is you can simply put an isolated foundation like this. Okay. Or you can provide some steep foundation like this. Okay. Where you are supporting multiple columns by means of a single foundation, and sometimes a single slab is sufficient, or sometimes you may have to provide an extra beam like this. Here you can see, okay, this is the extra beam, or you can also call it as a foundation beam. And the last option is your deep foundation, or you can say that well or pile foundation. You may have multiple pile, and above it you may have some pile cap like this, and then you are supporting your column. Okay, so I'm not going into the detailing about isolated foundation or the piling foundation. In this video I will discuss about this. Yes, second option, that is your steep foundation. So when do we need a steep foundation? Of course, when an isolated foundation is not sufficient and a pile foundation is not needed. Okay, basically when you have a moderate category load, or you can say that the soil bearing capacity, of the soil is not that much good. Okay, if the safe bearing capacity is good, in that case the isolated foundation is sufficient for a moderate category load. But if the safe bearing capacity is not that much satisfactory, or if the load is slightly on the higher range, in that case we may have to use this steep foundation. Okay, now this is very you can say a diplomatic answer. Okay, so as an engineer, we always have to give answer based on data. Okay. So first let me erase this one. Okay. So let's say this is the load coming on this column P, and this is the load coming on column B. Let's say this is Q. This is column A, and this is column B. Very clear? So now based on your safe bearing capacity of the soil, you can calculate what is the area required for an isolated foundation. So let's say for isolated foundation, area requirement for column A is, let's say, this is the area requirement. Okay. So if you are supposed to provide an isolated foundation for column A to carry this load P, what you can do, you have to provide this much area based on the safe bearing capacity of the soil. Okay. Now, based on loading condition and the same safe bearing capacity of the soil, let's say the area requirement for this column B is, let's say, this much. Okay, so now you can see that we have an overlap zone. Here you can see this is the overlap zone. So this is the case, you cannot go for an isolated footing. It is not allowed because the area requirement is much higher and you do not have much space to provide this area. So in this case, what is the option? The option is you can simply combine these two footing. You can simply combine these two isolated footing to form a single footing, and this is known as steep footing. That's it. Okay. So now you have got the idea when you need to provide the steep footing. Okay. Now what are the components of a steep footing? Here you can see that simply to provide the bearing capacity, we need a slab type element like this. Okay. So this is known as the footing slab. Okay. So here you can see in this actual figure, in this actual work, this is the slab footing. Okay. Now there is another part that is known as the foundation beam. That is, this is the beam. Now why this beam is required? Why this slab is not sufficient? Well, let's understand. So at the very first, let's say you have an isolated footing like this. This is the column and this is the footing slab. You have a load like this. So based on this loading, definitely at the bottom you will have some reaction like this. And due to this reaction, if we take only this particular zone, in that case this is fixed. Okay, so this is the UDL. So what is the bending moment diagram? Simply the bending moment diagram is something like this. Okay, so this is the bending moment diagram. And here you can see, based on this bending moment diagram, this is the hogging bending moment diagram. So this is bending like this. And as a result, there is a tendency that at the bottom of the concrete there will be crack. Why? Because concrete is weak in tension, and here the tension is being occurred at the bottom. Okay, and at the top there is compression. So to resist this tension, or you can say to resist this crack, what we can do? We can simply put this reinforcement, and I am talking about this footing slab. Okay, so by providing this reinforcement, you have actually resisted the cracks that's supposed to occur at the bottom of this footing slab. Okay, now let's say in this particular strip, you have a multiple number of columns. Let's say you have 4 number of columns. Okay, in all of these 4 columns there is load. So based on this load, at the bottom you will have a reaction like this. Okay, now based on this reaction you will have some bending moment. If you draw the bending moment diagram for this particular structure, you have a bending moment diagram like this, and this. So here is the first support, this is first support, this is second, and this is third, and this is the fourth support. Okay, and here you can see that at the top we have tension. Okay, but it is only for this span like this. So here we have tensile cracks, and at the bottom here we have tension only at this support location. So here we have tension like this. Okay, so based on this particular span, you have a magnitude of this bending moment. Okay, clear? So if the span is long enough, in that case the bending moment is also very high. And if you are supposed to provide only this footing slab, in that case, due to this higher bending moment, you need a huge depth like this. This is the total depth of this concrete. Why? You know that the moment carrying capacity of any section is simply the function of its depth. Mu is equal to constant times bd square. So b is the width here. This is the width of this foundation, steep foundation, and in actual case, this is the width. So this is the width of this foundation. So this is the width. Now let's say this column to this column, the span is very high. In that case, the bending moment occurring in this zone, or in this zone, and this middle span is very high. So to carry this high bending moment, what you have to do? You have to increase the depth of the footing slab, because B is fixed. B is this one. Okay, so this is the B. So to provide a huge depth here, your structure may not be an economical structure. It is not at all economical. So you have to reduce this depth of this footing slab. So in that case, what you can do? Simply you have to add a stiffener in this zone. So this is the stiffener, this is the stiffener, and this is another stiffener. Correct? Now the question is how you can provide this stiffener. As your foundation is a concrete structure, you can provide this stiffener by concrete only, and only in that case the compatibility will be maintained. So the concrete stiffener is nothing but a beam like this. Okay, so this is a simply beam. So now you have got the idea about the foundation beam. So what is the foundation beam is basically, it's nothing but a concrete stiffener that is provided to reduce the depth of this footing slab, and it is mainly required when the span is much higher. So if you have a higher span like this, definitely you can calculate this bending moment. Now if your bending moment that is coming as m is not equal with k times d square, where d is the depth of your footing slab, this is the depth, this is d. In that case only you have to provide this foundation beam. Clear? So now you have got the idea why this reinforcement has been provided, to resist this bottom crack. Now why this beam has been provided, to provide the stiffener characteristic in this footing slab if the span between the column is very high. Okay, so that's all about this stiff foundation. If you like this video, don't forget to share it.